So in this video, I am going to go ahead with question number 12 right through the end of the question paper. And the paper is 2021, February, March exam, paper 2, that's version 2, written down there. So I've already done number 12. I'll just go ahead and explain, and then we move on to the next question. Number 12 says the diagram shows a shape made from a quarter circle and a right angled triangle OBC. The radius of the circle is 5 centimeters, so this is 5 centimeters. OC is 6, there is OC there. And then because this is the radius of a quarter of a circle, this is also the radius. So I'll go ahead, solve this quick. So the area of a triangle is half base times height. There is it. Half base times height, and the base is 5 from there. The height is 6. I just plug in the numbers. Half of 5 times 6 is 15 square centimeters. You can just punch that on your calculator. A quarter of a circle is a quarter of pi r squared. Remember, the formula for area of a circle is pi r squared. So pi r squared is a quarter of pi times radius squared. Radius is 5 from this part. Radius is 5 there. I'll go ahead and punch this on my calculator. So this is pi times 5 squared, which is 25, divided by 4 because it's a quarter. I'll get 19,63. Then I'll take note of that. I'll write it down there. And then because I got 15, I'll go ahead at 15 to find the total area of my figure, which is 3,63495,408. I'm going to round off to 3 significant figures. It's going to give me 34,6 square centimeters. That is number 12. Number 13, the population of one variety of butterfly is decreasing exponentially. So when a population is decreasing exponentially, it is going down instead of increasing. So the rate is 34% per annum. At the end of 2014, the population was 125.9 million. Calculate the population at the end of 2019. So you see that from 2014 to 2019, this is 5 years. End of 2014 and end of 2019, that's 5 years. So I'll go ahead, write down the formula. Final number equals to principal, or the original number, 1 minus this negative is coming in here, since it's a decrease rate over 100 to the power time. So we know that the principal amount, the principal population is 125.9 million. 1 minus the rate is 34%, the rate is there. So it's 34 over 100 to the power 5. So let's go ahead, do this calculation. Let me start by saying 1 minus 0.34, because 34% is 0.34. I'll get 0.66. 0.66 to the power 5. So I'll go ahead, raise this to the power 5. I'm getting 0.125233 something. Then I'm multiplying by this number there, times 125.9. What am I getting? 15,766,86,713. Again, rounding off to 3 significant figures. What will I get? I will get 15.8 million. So I'll go ahead, write that answer down there. Take note that when you are rounding off, we're supposed to round off to 3 significant figures according to the question paper. Right. Let's go to number 14. There it is. Number 14 says these are the first 4 terms of a sequence. We have 29, 22, 25, 8, and 1. So we want to write down the next 2 terms there. So for us to be able to write down the next 2 terms, we need to find the common difference here. 29 minus 22 is dropping by 7. From 22 to 15 is dropping by 7. 15 to 18 is dropping by 7. So it's dropping by 7 every time. So that's why you have this -7 throughout. So we want to write 2 terms after 8. So if it's dropping by 7 at each level, so here is going to be 8 minus 1, you get 8 minus 7, you get a 1. There is your 1 there. From 1, it is going to drop by 7. There is -7, you get -6. And your final answer, -6 down there. So that is how it's done. Moving on to the second part, it says these are the first 5 terms of another sequence. Find the nth term. So let's look at this. 4, 7, 12, 19, and 28. These numbers are decreasing. There is a difference of 3, difference of 5, difference of 7, difference of 9. So 4 and 7, there's a gap of 3, there's a gap of 5, and so on and so on. And then these common differences, they've got a common difference between them. So 3 and 5, there's a difference of 2, 5, 7, there's a difference of 2, and so forth and so forth. So as you can see, these ones are not the same, but these ones are the same. So this is a quadratic sequence. So for a quadratic sequence, I'm going to use this to find my A, going to use this to find B, going to use this to find C. I'll show you how in a minute. So this one is 2A equals to this number there, 2, which implies that my A is 1, because if 2A is 2, you divide both sides by 2, you get yourself a 1. And then the next formula says 3A plus B equals to this number right there, okay, which is a 3. We got 1 there for A, so this is 3 times 1 plus B equals to 3. B equals to 3 minus 3. Then B is 0. I have a B. And finally, for the value of C, A plus B plus C equals to 4. So we put it there. This is my A, it's 1. B is 0. Plus C equals to 4. And we know that 1 plus 0 get 1 plus C equals to 4. 1 plus something is 4, so what is this? C? 3. So now I have A, 1, B, nothing, C, 3. What is the quadratic formula like in terms of n? The nth term is therefore given by the quadratic sequence, which says a n squared plus bn plus c, where a is 1, so this becomes n squared, b is nothing, c is 3. So your final answer, nth term, is n squared plus 3. Pretty good. Number 15 is a circuit theorem question. So in circuit theorems, there are theorems that we use to answer these questions. So let's look at this one. It says points E, F, G, and H lie on a circle where EG equals to EH. So EG is here, EH is there, and as you can see, this and that they are equal, meaning the angles at the base of that triangle, they will be equal. But what are they? Let's see later. FET is 47. And by the theorem of alternate segments, the angle subtended by EF is also equal to this angle. So this is 47, this is 47 as well. Because this tangent and this chord, they are forming an angle. So the angle they form is the angle subtended at the alternate segment there. Right, so this is 47. This is 25. There's a theorem that says angles subtended by the same chord or arc is the same. So this angle is the same as that angle because they're subtended by the same arc there. So I'll go ahead, 25 there. Since these are the same, 25 and 47, they are going to give me the angle at G. 25 and 47 is 72. So I'll write 72 there. So this is 72 as well. This is 72. So for me to find x, I'll say x equals to 180 degrees minus 72 plus 72. This will give me 180 minus 144. So x is 36 degrees. Done. This is usually a problem for many people. I'll try to simplify it as much as possible. So here we have got inequalities 1, 2, and 3. And you want to draw 3 suitable lines shading unwanted regions, and then finally labeling the region R, which is the region that we want. So for that, what do we need to do is to first make these equations instead of inequalities so that we draw the lines. Right. So the line y equals to 1 is a horizontal line and it must pass through 1 on the y-axis. So this line must pass through 1 here. And it's supposed to be a broken line because it's just y is greater than. It's not equal to, but it's just greater than. So because it's greater than, it's a broken line. Same applies to this one. It's going to be a broken line. And then this one, which is a greater and equal to, will be a full line. I'll try to get something to draw. Let me get a ruler. So I'm going to draw a line that is passing through 1 using this rule of mine, and this must be a broken line. So this is the broken line. As you can see it, I'll go ahead, label this line as y is equal to 1. And then I also want to draw these two lines. So let me do this. I'll create a small table, a mini table there, x here and y there. So if you can look closely, this grid where I want to draw, it has got x values from -1 to 4. So I'm supposed to pick any value between these so that I plot. So I can go on to pick 0 and pick 1. Of course, ideally I have to pick values which are spread out so that I minimize the mistakes. But there are reasons why I'm picking these two values there, so that I maintain my graph within this space that I have. So here, what I'm doing with this one, I want to know what is the value of y if x is 0. So the equation is y equals to 2x plus 2. So if x is 0, this will become 0. So that y is equal to 2. And I'll insert a 2 down there. If x is 1, y is 2 times 1 plus 2, which is 2 plus 2. That will give me a 4. Then I'll use this to draw a straight line on the grid. Let me show you how. So 0 and 2, they're a point. When x is 0, y equals to 2. Let's plot this right there. And then when x is 1, y will be 4. So I'm looking for 1 and 4. I'm going up. There it is, 1, 4. And then let's join these points. Try to be as perfect as possible. Again, it's a dotted line. So let me draw a dashed line. It's a broken line. We explained why. And this broken line is an equation y equals to 2x plus 2. Finally, I need to draw a line for this one. So let me go ahead and create a table of values. We have x and y. What if x is 0 and then y is 3? Sorry, when x is 0 and x is equals to 3, I want to find the values of y. So when x is 0, y is just equal to 3. So let me go ahead and set a 3 there. When x is 3, it means 3 plus y equals to 3. So it means y is nothing, because 3 plus 0 equals to 3. So it means this y must be 0. And then this will help me plot 0, 3 and 3, 0. So where is 0, 3? 0, 3 is right there. So I'm plotting there. 3, 0 right there. If I'm too fast, you can just pause, or you can slow down and then look at this carefully. And take note that this is not a broken line, because we said there is a less or equal to, so it's a full line. I'm not going to draw a broken line. This is a full line. So let's go ahead and draw this line. There you go. That's your line. So let's label this line x plus y is equal to 3. So all these 3 lines must be shaded. So how do we shade each and every line? So this line is y is greater than 1. So if y is greater than 1, y is above the x-axis. Here this side y is greater and then this side is less. So I will have to shade the unwanted region. So I don't want the less than, I want the greater than, because that's what the inequality is saying. For this other line, y equals to 2x plus 2, there is this side and then there is this side. So which side am I supposed to shade? I have to check again. Let's say I pick this point 0, 0 here. And I want to see if this point is it in the wanted region or in the unwanted region. It's simple. 0 and 0. This is x, this is y. So the equation is saying, or the inequality is y is less than 2x plus 2. But x is 0 and y is 0. So I'll say 0 is less than 0 plus 2 and 0 is less than 2. Is this true or false? According to inequalities, is true. 0 is indeed less than 2. So this region is true. So this point is true, this point is true, as long as it is on the same side of the line. So all these points are true. We want these points. So which ones are the unwanted points? The unwanted points are on the other side of this line. So this side is unwanted. What do we do with it? Let's shade it away. There you go. Finally, we have this line which has got the inequality x plus y is less than 3. So again, this line has this side as well as that side. So this side I can also test. I like using 0 because 0 is going to simplify my numbers. So if I use 0 and 0, would this be true? 0 is less than 3. It's proving to be true. So if it's true, I don't shade it. If it's not true, I shade it. So this point is true. It means it represents all these points which are this side. And since all these points are, which are this side are true, I'm going to go ahead and shade this other side, which is not true. So let's shade this side. Shade. Finally, the region that remains is this space. This is the space that will remain unshaded, and I'll go ahead and insert my R because the question says label the region R. That is my region R, which is not shaded. I guess this is easy to follow through. Number 17 says some of the students were asked how many books they each had in their school bags. So they are checking how many books do these students have in their bags, and the mean is already given as 7,6. Right. To solve this question, to solve for x, we are going to calculate the mean using this and equate it to 7,6. So we know that the mean is equal to the sum of x times f, where x are these values, f are these frequency values, all over the sum of frequencies. So this means summation of number of books times the frequency. So summation of 5 times 4, 6 times 5, and so forth, divided by the sum of all these numbers. So let's go ahead and do it. So we've got 5 times 4, 6 times 5, 7 times x, 8 times 11, 9 times 7, 10 times 5. All this divided by 4 plus 5 plus x plus 11 plus 7 plus 5. This will give us 7,6. Right. If we punch this in our calculator, it will give us 20, 30, this is 50. 50 plus 88 plus 63 plus 50. I'm getting 251 plus 7x. This divided by 5 plus 4 is 9, 20, 27, 32 plus x. All this is equals to 7,6. Then 251 plus 7x equals to 7,6 times 32 plus x. Here I'm just taking this and multiplying it by 7,6 that side. So it simplifies to 251 plus 7x equals to 7,6 times 32. I'm getting 243,2 plus 7,6x. Then the next step there is to collect like terms together and simplify. So let's collect like terms together. We have 251 minus 243,2 equals to 7,6x minus 7. And we are going to get 251, 243,2. This is 2,2. Sorry, let me 251 minus 243.2, 7,8. So 7,8 is equals to 0,6x. Divide both sides by 0,6. You will get x is 13. Your final answer. Let's move to the next question. Number 18. Number 18, we want to simplify 343 to the power 343 x to the power 9 all to the power 2/3. So this one we're going to do first by applying laws of indices. Right, there's a law that says x to the power a to the power b equals to x to the power a b. We'll apply that one. There's a law that says x to the power a over b equals to bth root of x all to the power a. So yeah, we'll apply these laws in answering this one. So first there's a bracket which is affecting which is affected by that power. So this means that 343 is affected by this power, as well as x to the power 9 is affected by this power. So from this law, you'll see that I have to multiply the powers. And then from the bracket, you know that 343 is that power. And then I'll go ahead to apply this law on 343 to the power 2/3. It becomes the cube root of 343 to the power 2 times x to the power 9 times 2/3. So I'll use so if you look at this, this is 9 times 2 over 3. 3 goes into 3, 1. 3 goes into 9 2 times. Sorry, 3 times. 3 times 2 is 6. So this becomes a 6. And 343, the cube root of 343, this is 7. 7 times 7, 49. 49 times 7 is 343. So this becomes 7 squared, x to the power 6. And we know that 7 squared is 49, x to the power 6. Done. So if you do not want to go wrong on these questions, you have to make sure that your indices are good. Number 19, solve this simultaneous equation and show all your working. So when you're solving simultaneous equations, you basically look at them and look for the most suitable way of solving them. So this is equation 1, this is equation 2. And as you can see, this equation, we have got x, we have y, which have got simple coefficients of 1. So in this question, you can make x the subject using equation 1 and apply the method of substitution. So x is equal to 7 plus 9. If you take this y to the right, you remain with x, and the right hand side becomes 7 plus y. Then you substitute 7 plus y for x in equation 2. Meaning you are going to remove x, and in place of x, you will have to write 7 plus y. So in this equation, x is squared, so you write squared plus y equals to 149. So this is 7 plus y times 7 plus y equals to 149. 7 and 7 will give you 49. 7 times y, 7y. Y times 7, 7y. Y times y, y squared plus y equals to 149. If you want to take this 149 to the left, you will have 149, negative 149 plus 49 plus 14y plus this y squared equals to 0. So basically, you are taking everything to the left, and then we simplify coefficients. So you will have y squared plus 15y minus 100. All this is equal to 0. Okay? And from the look of things, I can factorize this. I put y here, I put another y there, and then I look for two numbers. These numbers must give me negative 100 upon multiplication. Upon addition, they will give me 15. So the number that will give you 100 when you multiply, we have 100, we have 5, we have 20, So basically you have 20 and 5. But remember, the number is supposed to be negative. So it means the 20 is the one which is supposed to be negative because it's bigger. So this is minus 20. This is, sorry, I'll repeat that. The 20 must be positive so that I get a positive sum. So 20 minus 5 is 15. So the 20 is positive and the 5 is negative. So this is, so if you say 20 minus 5, you get 15. 20 times negative 5, you get negative 100. There you go. So this one, y plus 20 is 0, implies that y equals to minus 20, or y minus 5 equals to 0 implies that y equals to 5. Therefore, y is equals to minus 20 or 5. Okay? So what is x for each situation? So let's say y is minus 20. What is the value of x? You go back to our equation. You can use the original equations or you can use this one. I prefer using this one because this one is x expressed as subject already. So x equals to 7 plus y. So if y is negative 20, x is 7 minus 20, which is minus 13. I'll write it here. If y is 5, so what is x? X is equal to 7 plus 5. So x is 12. Where do I write my answers? I'll write 12 and y equals to 5. X is minus 13 when y is negative 20. That's it for number 19. Let's look for question number 20. Here it is, number 20. For number 20, you are given two similar triangles, and it means that this angle here is the same as that angle. This angle is the same as that angle. This one is the same as that one, such that the opposite sides are always similar sides or corresponding sides. In this case, 61 centimeters corresponds with x, and 2,8 centimeters will correspond with 3,2. So this side is this side in that shape. This side is that side. So you can go ahead, cross multiply, so that you get 61 times 3,2 equals to, I'll correct this. This is 1,61. So 1,61 there times 3,2 is equals to 2,8 times x. And then divide both sides by 2,8. 2,8. What is your x? Your x is supposed to be 1,61 times 3,2 divided by 2,8. You will get 1,84. So 1,84 is your x. There you go. And these are centimeters. Part B says the diagram shows two mathematically similar bowls. The larger bowl has a capacity of 7,8 liters and a height of 11,5 centimeters. The smaller bowl has a capacity of 4 liters. Okay, so the capacities of these bowls in the ratio 7,8 liters is to 4 liters. And capacity, remember, it is volume. So for you to obtain a volume from a length from a shape with sides, you have to cube the length. So for example, volume is given in cubic centimeters, but the length is given in centimeters. So for here to here, from centimeters to cubic centimeters, you have to cube them. It means vice versa is the cube root. So these are supposed to be cube rooted. Cube root of 7,8 is to cube root of 4 in order to get ratios which are equivalent to the ratio of length. Because here they are saying calculate the height. The height is a length. You don't know this one. We know this one is 11,5. So after cube rooting here, you are going to say this is not known, so you write h. This is known, you write 11,5. Cross multiply h times cube root of 7,8 is equals to 11,5 times cube root of 4, and then you divide both sides by the cube root of 7,8, cube root of 7,8, so that h is the 11,5 times the cube root of 4 and the cube root of 7,8. This will give us, let's do this one, 11,5 times the cube root of 4 divided by the cube root of 7,8. This will give us 9,204. And so forth. So to three significant figures, this answer is going to be 9,20, because we round off at this point. 4 is less than 5, so it's just 9,20. That is it. Right, number 21. Number 21 says sketch the graphs of the function y equals to 1 over x. So what is the value of y when x is equals to 0? Let's check. So this will become 1 over 0. So what is 1 over 0? Is saying error 2. This is indeed infinite, a very large number. So let's say we do not have a value of y when x equals to 0. So what do? We don't plot any points along this line. So whatever graph that we have, it will not touch this line. Neither will it touch this one. And these lines are called asymptotes. Asymptote, because you do not have to touch them when you are plotting this graph. But what happens if, say, x is too small? Let's say x is 0,00001. So let's check. 1 divided by 0,00001, we're going to get a very big number. So it means for small values of x, we have got greater values of y. And then for bigger values of x, let's say 1 divided by 1 billion, whatever, we're going to get a very, very small number. So as you go up, the values of y are becoming smaller. As you go down, these ones are becoming greater. So the graph is sort of like this one. And the same goes on the other side. So this is a graph of y equals to 1 over x. In general, it's like this. So remember, never touch the axis lines because they are asymptotes. This is y equals to 4 to the power x. So let's start again by checking at 0. So 4 to the power 0, we all know that 4 to the power 0 is 0, right? Sorry, 4 to the power 0 is 1, because any number to the power 0 is 1. So at 0, the graph is going to pass through point 1. What about if x is 1? So 4 to the power 1 is 4, 4 to the power 2, 16, 4 to the power 3, 64, and so forth. So the number keeps on increasing by a very large factor. So this graph will be going very up there. And then for small numbers, it will decrease and decrease. For example, this is 1/4, 1 over 16, 1 over 64, if the x values are now negative. Okay? If x values are negative, it becomes small and small and small and small. So this is the graph, a kind of exponential graph. That is how you get your values for that graph. So when you are sketching, just indicate important points. You don't have to really plot values, just indicate important points. 22 says a bag of rice has a mass of 25 kgs to the nearest a kilogram. Calculate the lower bound for the total of 10 bags. So in this situation, we are given that is to the nearest a kilogram. So the lower bound for this one would be 24,5. Right. For example, the upper bound would be 25,5, but the lower bound is 24,5. So because you have 10 bags, you just say 24,5 times 10 bags. This is 245. You write your answer that side. And then Virat has 200 meters of wire, correct to the nearest meter. He cuts the wire into n pieces. Each is length 3 centimeters, correct to the nearest centimeters. So calculate the largest possible value of n. So the largest value of n is found by saying length of the wire, you take the upper bound, divided by the length of each piece, you take the lower bound, because you want the largest possible. So you divide a very big number by a very small number, the biggest over the smallest. Upper bound for the length of the whole wire over lower bound of the length of that piece. So the upper bound here, remember, is to the nearest meter. So half a meter is 0,5. There you go. 200,5. So it's 200 plus 0,5. You get 200,5. And then the lower bound here to the nearest centimeters, 20 centimeters, it means half of this is 10 centimeters. So the lower bound is 3 meters minus 10 centimeters, which is 0,1. You'll get 2,9 meters. So I'll divide this by 2,9. Because the lower bound, you are going to subtract half of this 20 from what? From the length. So if you divide these two, let's divide these two, we will have 200.5, divide this by 2,9. I'm going to get 69.137, 69,137, and so on. So the largest possible value of n is 69, because we are talking of the number of pieces that I'll get. That is it about number 22. Let's move to number 23. Number 23 is a graph, sorry, is a a pyramid which is let's put V, A, B, C, D. So this is the pyramid, and we have got a square base or a rectangular base, So the rectangular base will look something like this if we are going to draw it separately. And we have 14 here. Sorry, this is 10. So let me label, this is B, this is C. This is A, this is D. So for the other side, AP, this is 12, 12, 12. So AC is the longer, is a diagonal there, which passes through M.